Hello everybody, I am Ben from Team Panic, and today I am throwing out a challenge, and I'm also going to take on that challenge. And the challenge is this. Imagine that you have absolutely nothing and build a combat robot for the cheapest price you can possibly do it. Now, what I mean by this is not necessarily that you absolutely have nothing, but every single thing you use to build the combat robot, you have to add into the price of the combat robot. So for example, if I was to turn around right now in this challenge and print something on one of my 3D printers, I would have to add 500 Australian dollars into the cost of building the robot, because that's what the cost of those 3D printers is. So for somebody to get from no robot combat parts to holding that 3D printed object in their hand using my method, it would cost them 500 Australian dollars. Now, what I've got in front of me is around about $60 or 60 Australian dollars worth of parts. And I'll run you through all of these in a second, but why I'm bringing that number up is because it is roughly the cost of this FlySky FSI6 transmitter, which is a fairly standard beginner's level transmitter for a combat robot. Now, if this is your first video of mine that you're watching, or you're looking at this to attempt to do your first build and taking some ideas from the stuff that I do, please watch all the way through to the end, because right at the end, I will show you how well or not well this works, and I will give you my personal opinion as to whether or not this is actually worthwhile. But like I said, I'm throwing this out as a challenge to the community. I want other people to take this on, and I want to see how cheap people can go and how good people can build robots for very minimal price ranges. And I mean, like I said, a traditional transmitter is about 60 bucks. So if you can get under 60 bucks and still build something combat worthy, I am going to be really, really surprised, and I'd be really keen to see that type of build. So let's take a look at the tools and equipment that I have in front of me. One thing I will say too, by the way, is that the pretend you have nothing doesn't include household items. So a pair of scissors, for example, don't add that to the cost of your robot, because most houses will have a pair of scissors somewhere around the place that you can grab hold of and cut up plastic parts and whatever else. But find little screwdrivers that you need to pull something apart. I would add that in. Most places would have a screwdriver maybe, but not kind of tiny little jeweler screwdrivers like these. So let's take a look at what I've got. Okay, so let's start with some basic stuff. So tools, I have a hot glue gun, glue sticks, these precision screwdriver kit thing. I have a barbecue lighter, but you could use literally any type of lighter for this. And I've also got some super glue, and altogether it's maybe $15 worth. I think the hot glue gun and the glue sticks are about 10, and then the rest of it is kind of, yeah, up to kind of 15, maybe $18. Then I've got a Lego vehicle, which I've already gone ahead and made. I mostly got this for the wheels. Now, the wheels you could do cheaper than this if you decided to buy parts offline. If you get some like Pololu wheels or something, those would work just as well as these. But I tried to do things from kind of buying stuff from stores around me rather than relying on online shopping. I could have done this a little bit cheaper online shopping for sure. Speaking of, the main component of this is this wall climbing RC car, which is around about 30 Australian dollars. It's one that I brought up in the hacking RC cars video because it has nice proportional controls, mixed steering, and it runs a 2.4 gigahertz transmitter. It doesn't have proper binding, but I've been told that there are some competitions where this setup will be legal if we run it as a wedge, which you can tell by, maybe you can tell by the parts I have here. A wedge is all we're really aiming for to build at this point, because there's nothing here that I could use to build a weapon with. And let's be honest, adding a weapon into this thing is going to significantly increase the price. So we're just going to go for a basic wedge, and that's about that. Then the chassis is this. This is actually a cat litter tray. Now, there's lots and lots of different types of plastic trays and tubs that you can get out there. I went for this one mostly because it doesn't actually have a recycling symbol marking on it anywhere on the bottom. And if you get a recycling symbol marking, that means that it's some form of thermoplastic, usually polypropylene, or there's another one, PETG. And normally those things are quite thin, and you'll find polypropylene around a lot. I am hoping that this tray is either ABS or PLA. I think it might be ABS given how much it flexes. Can't really know for sure, but I'm basically just hoping it's a little bit more sturdy than some of those like clear plastic tubs that you would find around the place for storage and that type of thing. So that was my idea for this little guy. Yeah, all right, so I think I'm going to start by pulling our little controller, our little car here apart. So already not doing very well. This cheap set of precision screwdrivers is garbage. It's from basically essentially a Walmart here in Australia, and yeah, it's just terrible. So this is about $3, and I'm upgrading to my screwdriver set, which actually has a lot more bits in it that are very useful actually. And this thing probably cost me about $5 more than that originally, so let's jump the whole price of this thing up to about $65, but now I can actually take the screws out at the front of this thing. So yeah, if you are buying tools, go to a hardware store and buy something that, even if it's not like the most expensive thing they have, there's just a little bit more quality than something you'll find in a shop that also has a toy section where you can buy Lego. Yeah, so here we go. We're now inside this car, and you can see we have twin LEDs at the front, or maybe you can't see that. There are twin LEDs at the front, and we've got drive motors, 2 of those, and we've got a fan in the middle here. So I'm just going to pull the rest of this apart, and then we're going to have a look at what we've got. Here's what we had in here that was of interest to us. So we've got a tiny little 1S 75 milliamp hour battery, which will be enough to last a fight, running this thing for 3-4 minutes. We've got a left and a right motor with a gearbox stack up and an output wheel, which doesn't seem to like it's an easy thing to take off of here, so we're just going to leave that on. We also have a control board with a switch and a charging port, so there's charging circuitry on here for our little guy, which is cool. Now we've got an antenna, we've got an extra motor that's got the downforce fan that we're going to cut off because we don't want it taking up any battery. We've also got some LEDs up here which seem like they're just hot glued in, so we should be able to free these pretty easily. We also got a whole bunch of screws over here which we're going to be using later, and then I've also got 2 extra wheels which I'm really hoping the round section on the front of these slots nicely into, yes, they almost perfectly lock into a Lego axle like that. So that's how we're going to glue all this stuff together later on, is we're going to be able to glue that and keep that relatively symmetric, and then glue that wheel on the outside of this wheel. It's going to be quite a wide stack up, but it might just work. Okay, so off camera I've done a little bit of cardboard aided design. Basically I took the box that the Lego truck came in, and I've just been kind of messing around with it a little bit, cutting a few different shapes out and just working out what kind of looks and feels about right. This currently sits a little bit too high. You can see the wheel only barely covers everything, but that's because I've got tabs on the bottom down here, which actually are supposed to be folded in so that the base plate can be attached down the bottom here. But I haven't bothered doing that because this cardboard design, I mean, it's fine, but yeah, we might as well just get on to making the real thing. The other thing too is that I went a little bit fancy in here. You can see these edge pieces where these motor mounts are. These are actually a triple fold piece that kind of gets cut out of the side panel and then folded all the way down. And yeah, that's going to be complicated and annoying, especially when I'm doing it by melting the plastic with a barbecue lighter and melting it and bending it that way. So we're going to kind of cheat on those, I reckon, and we're basically just going to fire the hot glue gun up and stack a bunch of plastic pieces until we get up to the right point. The other thing too is that I'm worried that this might be a little bit flimsy, so we may end up either, actually no, we won't be using this because even though this looks all right, it's probably a bit brittle. So we won't be using that, but we might end up doubling up a lot of our plastic. And even then I might try and like scavenge a rock from the garden or something just to put some weight in under the front section so that it doesn't pop wheelies every time it takes off, and or it's not, you know, 50 grams underweight or something like that. So, all right, I think it's time for me to kind of deconstruct this a little bit and copy it into our kitty litter tray. So that's the base shape cut. This stuff is quite flimsy, so especially these sidewalls, we're gonna have to bolster these quite a lot because you can see they kind of flap all over the place. But what we're gonna do is we're gonna get everything together and then we're gonna bolster with internal flaps and pieces. Now, the next idea for me was going to be to melt this stuff with a barbecue lighter and see if it bends. Now, the problem here is I don't really know what plastic this is, and some plastics do give off kind of noxious fumes. So I'm gonna do one quick test bend here. Just get it a bit hotter. You can see that one end is starting to curl a little bit away from the flame, which is interesting. This is not the type of plastic I thought it was. But let's see if we can hold a 90-degree bend. So that's what I've done there, just giving it a quick 90-ish. It's not perfect, but you know, no, we're not really going for perfect here. It's still a little bit flexible, still a little bit of heat in it. Let's just let that cool down for a second. Really not sure what this is. It definitely seems to be some form of thermal plastic though, because if I can get a good shot of this, hang on. It's actually curled up around the edges, which means it's shrinking in the heat. It seems to be holding its shape. I mean, this stuff is a little bit bendy and flexy, which I did mention before, but that's gone quite well. So we're just going to quickly bend up the rest of this shape now. So we're basically there. There's a little scorch marks on the top of this, which we can just kind of rub off. It didn't do a great job with my bending. You can see there's some kind of gaps and stuff, but that's where hot glue comes in. We're just gonna hot glue all of this stuff together just to make it sit nicely, and then I'll work on mounting the electronics up through the inside. All right, so now we're getting somewhere because we can throw the base plate in here, and we can actually, I can almost get it to like sit in here essentially. And actually having that in there does actually strengthen the whole chassis up, which is nice. If I kind of hold it a little bit in place, it stops some of the twist that happens in the chassis. If I pull this out, you can see I can kind of like get a decent amount of twist on the chassis. So we could almost not have any other reinforcement in here and put just the bottom on it. The thing that I'm wondering though is how to do this. Now I did mention having the curled over pieces of plastic in here, but I'm also realizing that our little electronic stack up over here, it has the switch and a battery charge port on it. So realistically, as long as both of those are exposed, we don't need to get inside the robot ever, because most of the time I go inside a robot, it's to unplug the battery and get the battery charged. But this literally has a charge port on it, this little white square at the front here. So theoretically, I could just seal this shut and just charge the battery externally and everything would be fine. All right, wheels are in, and they look ridiculous on the side of this thing. Check that out. Look at that. Tiny little weeny baby wheels sticking out the side, and then we're of course gonna jam some big old wheels on. I have no idea how well any of this stuff is lining up. This is probably not gonna work, but we're gonna charge on right ahead. And this thing is becoming just a massive hot glue. I bought some super glue thinking I was going to use the super glue. I have not really used the super glue for anything so far. I've also cut a notch in the back, which is where we're going to be able to get to our switch and our charging port. Yeah, we'll glue all of this stuff into the base plate at some point in the near future. And then, yeah, once we work out how the base plate attaches, then that will be our way to turn this thing on and off. All right, next things next is to try and mount up these wheels and keep these as concentric as possible. Wish me luck. All right, well, that's the wheels on. This is something of a moment of truth. Let's turn this on. All right, seems like we're connected. Oh, okay. Well, the wheels move. That's a good start. Let's flip this over. We're just gonna leave the wiring hanging out the back of the thing to start with. If I can, carefully. All right, cool. Well, it sits up on the wheels. Also a good start. Well, it drives. Nice. Yeah, we're definitely gonna need some more weight in the front of the thing, but that's okay. I was kind of expecting that. Now, the other thing too I'm realizing is, as you can see, we don't actually need these LEDs. There is an LED on the board which indicates that the thing is on, and that you should be able to see through the hole in the back once everything is in place. So these LEDs we don't actually need, and in actual fact I'll probably just ditch them because they just seem to be driving LEDs. Yeah, so they're just on while it drives, which, cool, I guess. But you can see we're on our way. So if I slowly, yeah, look, we can get low speed. Whee! Cool. All right, this is gonna work then. It is one of the weirdest looking robots I think I've ever made, but that's okay. We're going to fix the wedge because you can see. Maybe you can't see, but right now we're touching on one side and there's a gap on the other. In fact, here I can show you that. Look, you can just literally like poke a whole screwdriver in under there, which is really not great. So we're going to fix all of that. I'm going to armor up a little bit more. I'm probably going to add a ton more plastic to this because I have a feeling we are ridiculously far underweight. In fact, I will check that in a minute. But then I'm going to start slapping some more armor panels on here and things. I was considering wheel guards, but considering how far these wheels go out, I don't think that's entirely feasible. But like I said, at the very least, it actually moves. So that's cool. All right. More stuff. This video is getting kind of long, so I've kind of skipped a few steps here, but basically all you've missed is we were really underweight. This thing was like 50 grams, so I jammed a whole bunch of rocks inside of it, which were literally just rocks out of my garden. I went outside and picked them up. I also bent up a little claw to sit on top here, which is actually mostly so that it rides correctly upside down and the wheels still touch the ground, just as you'd expect. Speaking of it being upside down, I also went the easy way out and just hot glued the base in place after hot gluing the electronics in the back. Yeah, I ummed and ahed about the little mounting points for a little while and then just decided that it wasn't worth it. This thing, I'm probably going to test once and then I'm going to pull it all apart and I'm probably never going to touch it again because it is all just a little bit wonky. But now that it's all together and we've got weight, a lot of weight in the front, I'm just going to have another quick test here. So we'll get our controller out and pull the camera back out a little bit. There we go. And then get this into an on position, either one of them, because it has two on positions, but it doesn't matter. As long as it's in one of those, we'll be all right. So, nice. Haha, it's actually, honestly, speedier than I thought it would be, because these motors were really slow in their original setup. Those tiny wheels meant that it was really slow. It does seem to have a preference towards one wheel. I have a feeling this wheel is rubbing a little bit, which is slowing it down and causing the robot to turn a little bit as it's supposed to be driving forwards, but that is something you could actually fix, I reckon, pretty easily. That is more impressive than I was expecting. Now, the final thing we have to do here is actually turn all this off, because I don't really want to be working on the robot while it's on. Come on, off, thank you. So, as I mentioned a lot earlier, the wedge has got massive holes underneath it. So, what I'm actually going to do is I've got this packet from these glue sticks, which I've burnt through a dozen or more glue sticks tonight. Or in this video, I should say. It has actually been more than a single evening's worth of work on this. But we're going to use some of this thin plastic here to finish out the wedge and just, yeah, get all this stuff working, because this nice thin plastic will give us the ability to get under people and also kind of bridge that final little gap. So all I need is just enough to kind of get in underneath here, just like this. And then we'll glue that down, and hopefully this stuff doesn't warp when we glue it. But if it does, it's quite thin, so we should just be able to bend it a little bit and make it fit where we want it to fit. So, all right, that should do that job. Hot glue. Oh man, this thing has got so much hot glue in it, it's not funny. I mean, that's a little funny, but it's also not. I really probably should have used a little bit more super glue, but there we go. Now we have a nice front plow, which, yeah, that actually springs the robot up a little bit. So that means this front plow is definitely the first thing that's hitting an opponent, and it's going to scoop them up. Beautiful. That is what I like to see. It works! It works better than I was expecting, to be perfectly honest. Considering that half of it is held together with hot glue and the wheels are double stacked out with hot glue, it survived. I think that if you're a beginner, this is a perfectly feasible way to get into the sport. You could potentially throw $60, $70 at the problem and have a combat robot that would last you through an entire event. Especially if your event allows you to have kind of more lax binding on a wedge-shaped robot, which apparently some of them do, which is really cool. So you can, if you're a beginner, you can do this. Should you? I don't know. Look, if you've got $60 to your name and that's it, by all means, go ahead. I would probably recommend learning some online CAD software like Tinkercad and 3D printing a chassis rather than cutting and bending it, because you'll get way more accurate results that way. But if you can scrimp and save a little bit more, going with a conventional RC setup and kind of the parts list that I did in my beginner's spinner video, which I will link in the description and at the end of the video, if you go with something like that, then the replacement parts are a lot easier. This guy, if any electronics fail, you're buying the whole car again, which is kind of more expensive than in this case, where if one of the electronics fails, you swap that out. So this is like a $5 part over here versus a $30 part over here when damage happens. For my builders out there, my fellow builders out there, please do take this challenge on. This was a lot of fun. Despite the fact that it's come up with something that, like I said, I think would last a competition, but not very much more, it was really interesting to do, and I'd love to see other people take this on and see other people's approaches to getting a robot out at the cheapest level they possibly can. Because this is just one example of how you can do that, but I'm sure there are others out there that I've missed, and that's kind of the reason I wanted to pose this challenge, to see what other people could do with this type of constraint. So please take this on. If you do manage to do something like that, throw it on Facebook. There's a Facebook page which I'll link down below, or my Facebook page I'll link down below, or just in the Combat Robot Facebook page in general, or throw it on Instagram, or leave it in a comment here or something. Please send me your examples of this challenge, because I'm very, very interested to see what people do with this. So anyway, I hope you guys have enjoyed that. I hope some of you take this on, and I will see you in the next video.